Hello everyone, welcome back to the workshop. Today we are looking at the Neje 3 Max V2, and I'm kind of excited about this one for a few reasons. Number one is its kind of form factor. The frame is laid out wider than it is deeper, and as a matter of fact, if you're a long-term viewer of this channel, you know I've had my 60 watt CO2 laser for a while, and that one is roughly about a 700 by 500 millimeter working area, or that comes to be about 27 by 19 inches. Well, this one is actually about 31 and a half inches wide and 18 and a half inches deep. So it's a diode laser with actually a wider footprint than my CO2, just a little bit shallower, but that width is what really intrigues me. I originally got into using lasers for my model aircraft hobby, and a lot of times I'm dealing with 36 or even 48 inch sheets of balsa, and so the 27 inch width of my laser really meant that I was restricted to about a 24 inch sheet of balsa. And so this really lets me step up, not quite to that 36 inches, but it gets me a lot closer. And the form factor that it's wide instead of being deep, a lot of the lasers give you rail extensions where they'll go deeper and your origin is up on the front left. And you know, the way you're working with it, often it's sideways, and you know, you kind of mess up your origin. This one solves that issue. So I'm really excited to look at this just kind of in the way it lays out as more of my comfort zone and such. But it's got some other cool features to it, and we are going to dive into that. So if this is something you're interested in and want to find out how I'm using it, or want to find out more about the Neje 3 Max V2, stay tuned. We're going to get right into it. Let's first talk about the basic specifications. All right, so I mentioned that the working area of this one is a little bit larger. So the technical working area is 790 by 470 millimeters, so that comes out to be about just a hair over 31 inches wide and 18 and a half inches deep. Now they do have extensions that are available for this, so that will extend the depth to about 1,030 millimeters, or right around 40 and a half inches deep. So that would be a very, very long working area, but also is still giving you that 30 inches wide. So one of the larger ones that is out there if you do get those extensions. Now the frame size is a bit bigger, so there's a cable chain and there's stepper motors, things that hang out from the sides of the frame. So you're looking at an area of about 970 by 582 millimeters, or roughly 38 inches wide and 23 inches deep. So if you're looking at an enclosure or just kind of a working space, you're going to want to plan for almost 4 feet wide and then just over 2 feet deep as kind of your minimum working area. Now the frame and the components are made mostly out of aluminum with a few steel pieces. The bulk of the frame is made out of 20 by 40 millimeter extrusion, and it's also anodized and very smooth. All the quality of the parts, I didn't find any issues with burring or any kind of variations and such. So you're using quality extruded parts, and then some of their plates for the stepper motors and such are very well cleanly milled out aluminum blocks. So some of the features on this laser that it includes, you know, you have your typical aluminum frame and such, but with that they also have limit switches. They're not big and bulky, they're off in the corner, you might actually miss them, but when it does start up, it is going to home actually back into the rear left corner, but then its origin is actually still in the front left corner, which works out really well for me. I like it when the laser head moves out of the way to the back left. On my setups, even if it homes in the front left, I will tell it to, at the end of the job, usually go back to the rear left corner. It just gets the head and the gantry out of the way. So one of the biggest things on these diode lasers that we've talked about in the past is cable management. Well, they offer cable chain in both the X and the Y axis. It runs everything through that, so it really keeps that cable out of the way. It does add a little bit of a bulk to the side and the rear. You got to count for that when, you know, planning your enclosure. There's going to be a little overlap on a couple of the areas, but it does help make sure that cable stays out of the way, that they make it to their ends without any problems, and it's not dragging across your material, and it shouldn't be snagging on things, and generally will also keep any strain away from the cables getting pulled and stuck in areas they shouldn't. One of the other cool features is they offer both an M7 and an M8 relay. So of course these can be used for air assist, but you could also use the secondary one for another option. Perhaps you want to add a light to it that turns on while the job's in motion. And with that, they include both a pneumatic relay as well as electronic relay. So if you have your shop air supply and you have that with a moisture trap, you can definitely tap your air right into that. Otherwise, they do give a, I think it's a 12/24 volt relay that then you can use to power your air pump. And then using the M8 or M7 commands, you can have that triggered through light burn and such to turn on and off with your layers and your jobs. So it's nice having both. It adds a little bit of a kind of a tinkerability to it, and really happy to see that. One of the things I love with any lasers I'm looking at is that they have an emergency stop button. So it's going to be a big red button. Anything's going wrong, you hit that and that should kill all motion, kill the laser. And they do include one of these. Interesting thing is that they don't give you any sort of mounting area for it. This whole laser is kind of a good base to put into your own surface or into an enclosure of your own. So having the e-stop button not mounted to the frame is nice, because as you build out an enclosure of your workspace, you can actually move that away from the laser itself within reason. You've got a few inches of cable to work with to get that out of the way. But it is something you're gonna have to figure out on your own. Now, I will show you a little bit later that I used the laser to actually make a box, and then I mounted that to the board. And a couple other features they do offer is they have some nice belt tensioners that will allow you to kind of dial in your belt tensioning. Now, I'm not using these on all the axes because the way they're mounted on the laser makes it a little bit difficult to get at them as the adjustment screws come down on the bottom. And so this is something that I think is maybe a slight oversight on their part, in that if you were mounting this flush to a board and hard mounting it, it's gonna be hard to adjust those because they are so tight. Now, if you can raise it up on some risers, or if you can have some slots, or you don't have it in an enclosure or on a solid surface like that, then they're gonna be fairly easy to get at. But the way I have it set up, mounted on the board, they're actually kind of hard to get at. So I left them off on the lower rails, but they are really nicely designed. And so if you can work your enclosure or your mounting system around it, definitely I would use those. Otherwise, it would be great to just to see that adjustment screw, somehow either on the top or in some other way, so it's easier to access as well. And then on the laser head assembly, they do have a nice lead screw adjustment for the focus. So I think like a full turn is like 0.7 millimeters, and you have about, I think, 20 millimeters of travel that you can move the laser head up and down without making major adjustments on the side. So you technically have two ways to adjust it. You can loosen up the block and move the whole module and mount in the mounting block. And then they have the kind of the precision adjustment with the lead screw and the knob on the top of the laser. So this works really well. My only issue with them is that the knurled knobs that you need to tighten them down, they're really tight in on the laser, and they kind of sit flush, which is nice that they get out of the way, but it can also be a little bit tricky if you've got, maybe some bigger digits and you're trying to get your fingers in there. You just got to take your time, make sure you got them snug, because you will be kind of just getting at the ends of them at that point. But really nice that they do have this precision adjustment, and it's not, just a lever and a slide it up and down. You can kind of lock it in place into the gantry on the module, and then you can just kind of dial it in yourself as well. This laser is compatible with Laser GRBL as well as Lightburn, so you have your options of control software with that, and that works out really well. Of course, I'm going to be using Lightburn as I have in many of my others, and it was very easy to plug in. The Lightburn software detected it right away and pulled in its parameters, so it was very easy to set up in that vein. All right, so let's talk a little bit about the build. I'm not going to go into the full detail of building this one. I will warn you that this is definitely one that is more of a DIYer that is comfortable assembling things and wants to do a little tinkering. As I mentioned earlier, there's some things like the e-stop button that isn't necessarily built into the frame. You're going to need to figure out how you want to mount that. Kind of the same thing with the relays. They don't necessarily have a way for mounting that as well. But they do provide you an instruction book, but I will say this is small. I mean, look at this, is my hand. This is about maybe 4 inches square, and they do kind of walk you through it, and they give you some photos and such. This is an area I think that could be improved. Now, they do have a wiki with more information online, and you can get it that, and there are other build videos out there, but as far as if this is the first time you're building one of these machines and you're maybe a little uncomfortable with it, you're going to want to take some time, watch some of the build videos, look through the manual, and make sure you're kind of understanding each step. Definitely check out their wiki. It's not hard to assemble, but my complaint here is just this is a small manual, and they do look like in here they have good detail. but you're going to want to go and find this digitally online, and you're going to want to maybe, enlarge it on your computer or on a tablet to really see the detail of photos of what they're showing you to do. It does walk you through it. The parts did fit quite well. Some of the machining was very, very tight. Not so much that it was impossible to get, but you do want to make sure that your items are square. Otherwise, you could end up cross-threading some of your bolts as you go in there. But you want to take your time. You do have to work with the cable chain. So it comes with the cable chain. You're going to have to mount the brackets and the channel on for them to run. And then one interesting thing that I found is that they have the side channel for the cable chain, but it's kind of intended to be mounted to the surface that the laser's sitting on, which then kind of makes you to mount the laser as well. And they give you some clips. But at that point, it becomes less portable. And when you get to adjusting like the belt tensioners and then the eccentric nuts, it makes it hard to get at those if you've hard mounted it to a board. So I think it would be nice if they put the eccentric nuts for the rollers on the top wheels, because then you could get it from the top. And again, with those belt tensioners, if they could just maybe change so that the adjustment screw wasn't coming up from the bottom, that you could get at that from the side or the top. That would make those so much easier to adjust if you have it, hard mounted on a board or in an enclosure or such. All right, so let's talk a little bit about the performance of this machine. Now, this is a 20-watt module, and so I wanted to start out with my typical 1/8" Baltic birch plywood. And so I ran that through running with the air assist. And as you can see here, we were able to squeak out at 550 millimeters a minute at 100% power. And that was making clean cuts through the Baltic birch plywood. So 20-watt module, that's kind of right in there with what I would expect out of it. From there, I also wanted to test some more kind of poplar craft plywood to see where we were getting at. And this is much less dense than the Baltic birch, but as you can see here, we were able to get even at just 90% power through at 700 millimeters a minute. So definitely a jump up in performance for this lighter weight craft plywood. And again, very clean cuts. So along with that, then I wanted to try out some basswood, craftwood as well. And here again, you see we're cutting up into the 700, 750 at 100% power. So again, for a 20-watt module, this is performing quite well. And as you can see on the surface, the cuts are looking very clean. They're not getting a lot of smoke and overburn on this. So obviously the air assist was working very well. I also wanted to start trying some thicker material. So I went to some of my standard materials, and this is some sanded plywood, I believe, from Home Depot. And this is about 1/4 inch, maybe just a touch under. But there you see through this with kind of the lighter weight cores again, we're getting through this at 500 millimeters a minute at 100% power. Again, you might want to back that off a little bit with this. Just this stuff tends to be a little bit spotty and where you get some rough spots. But even so, 400 to 500 millimeters a minute, 1/4 inch plywood, looking great. I do a lot with Baltic birch, and recently I've come across this stuff locally here in the Midwest with Menards. I believe they call this like a birch tiger ply and such. So it's about it's got, if you can see that, it's got about 5 layers there, and so it's got a couple of thinner cores and then 3 thicker cores, and then our veneers on top and bottom. So that layers and glues adds a little bit. But we were still cutting through this at 250 millimeters a minute, both at 90 and 100% power. So still reasonable. This is definitely going to be far more structural than some of the other 1/4 inch and those light core plywoods. So if you're looking for some jigs and or something that needs to be able to take a little abuse, this type of wood would work well, and we can cut through that. Then of course I tried some Baltic birch 1/4 inch plywood, and again we're getting through at 200 millimeters a minute, getting a little more of that charring in the corners there from this one. So definitely as it's getting through some of these thicker, harder woods, maybe a little bit more resins in the glue, we're seeing a little more difficulty, but it's still able to get through there. Now, of course, cutting is one thing, but we also want to be able to do some engraving. So again, with that 15,000 millimeters a minute speed range, I ran one from 5,000 up to 15,000 and did a nice grid. And you can see definitely down at the 5,000, a lot darker. We're getting a deeper, engraved there. Definitely down about a good, almost maybe not quite a 16th inch there. And then up at the top here at the 15,000, it is there's just, you can feel it's in there a little bit, but it's still fairly dark, but then also coming very light. So, you know, if you're going for more gradients, obviously, you know, that faster range is going to work, but definitely if you want a deeper engrave on woods, you know, slowing it down into that 500 or 5,000 millimeters a minute range is going to work. But pretty decent quality throughout all that. And then I did go ahead and try more of a raster just to make sure that we were kind of getting to some of the speeds listed there. So this one I jumped up a little bit more, like every 2,000 from 5,000 up to 15,000, and you can kind of see a similar pattern there. 5,000 up on top is definitely darker and deeper up here, where down at the bottom it's not really going in too deep, but it's adding some color and going to almost clear on the side. So definitely gives us a good range to work with on engraving. So with our speeds worked out, one of the first things I wanted to do was make sure I could have a mount for my E-stop. So as you saw earlier, I have my laser set up on this board, and so I just drew up this box for 3mm or 1/8 inch plywood. And since I had already run my cables through, I needed to add the notch where I could kind of get the wire through. And then on the back side, I have just kind of a little hoop there for that to come out of the box. And then it's just held down by 4 screws in the corner, some little number 4 screws. But this works out really well. It keeps the E-stop button in there nice and easily, and then I can reset it. And that will work well, as it's just right off to the side of the laser. And if I need to, and if in the future I build this into an enclosure, I'll easily be able to take this off and either take it out of this box, or I could mount that box on the outside of my laser. That was one of the first projects made, and worked out well. And you know what? I'll try to put these files down below if you want to use this for your laser as well. So one of the things I like to do is run a kerf test on lasers. It helps me understand, you know, what's the gap that the beam is leaving, which also helps us identify, is that beam more square or rectangular? And so I cut a grid of 4 boxes here, and they were all set up to be, I believe, 25 millimeters in width and height. So it was very uniform. And then I cut those out, and then I label them so I can make sure to get them in the right order as I'm pulling them out of the laser. And then I go ahead and measure both the outside dimensions of the inner boxes, as you see there, and then the inside dimensions of the outer boxes. And what I came up with is that they were actually fairly consistent, which was good to see. Width and our heights of the squares were really pretty close. We're about 25.17 to 25.15 as far as the outer size, and that was giving us an average of 25.15 millimeters. And then the inside measurements were around 24.66 to 24.67, maybe on the lowest 24.58. And so we're getting a little bit of variation in the other axis. But overall, that gives us a total beam width of about 0.4 millimeter. Our kerf offset would be about 0.2. And so with that, seeing that they're fairly square with a little bit of variation, we can assume that they are pretty close to a square focus spot. And then, you know, you can't necessarily say that because I'm getting a 0.48 or almost 0.5 millimeter beam that's the focus spot. As the beam's going through, the burn and the kerf is going to get a little bit wider because of the material. But this at least allows us to see how square is that. So you know, the variation between the outer ones being within 0.02, let's see, probably 0.05 millimeter in difference, I'm going to say that it's pretty close to being a square beam with maybe some slight variation. Wanted to try out a thickness test, and so I've got this clear aspen. So this is like pine, but it's far less of a, it's got less sap and it's got less grain to it, so it actually tends to cut better than that. And this is 3/4 inch, so it's closer to like 19 millimeters. It's a little bit over their recommended 17, but went ahead and set that up at about 150 millimeters a minute and did 3 passes. Had to repeat those passes a couple times to get good clean cuts. But as you can see, it did get through there. The first cut was a little bit charred, so I increased the speed a little bit to closer to 300 millimeters a minute, and then reran it, added a few passes, still got through, and had less charring on it, but still some, and had a little bit of a spot on there where it just didn't quite want to cut through. So you can kind of see there's that little bit of a white spot where it didn't quite laser all the way through, and you're going to see that with natural material. All right, so diode lasers can't necessarily cut through or mark most metals, but they can remove anodization and they can work with stainless steel. So I had one of these business card type things. It's just kind of like the thin aluminum card, and then it's got this coating on there, and what you can do is burn it away. So this is kind of just a business card I sometimes cut out or mark out. And as you can see, it worked out fairly well. My settings on this were 10,000 millimeters a minute at 65% power. This did take about 8 minutes to finish this one. And so I think you could probably bump that speed up, maybe play around with your power. But the important thing is I wasn't really burning the aluminum or the steel here. It's nice and shiny. I did end up cleaning this up with just a little bit of LA's Awesome and a magic eraser thing, but it came out very clean after that. I mean, you can kind of see the reflection and the shine there. And so definitely something that's possible with these where you're wanting to remove anodization, maybe remove a paint layer, a silicone layer that has a metal underneath, or if it's stainless steel, you will be able to do some markings playing around with the speed and power. So just something to keep in mind that you can do with this as well. So one of the things people often ask with these diode lasers is, can I cut acrylic? And the answer is sometimes. And usually what it's going to be is the more dark opaque acrylics. And so black opaque acrylic is definitely one. So I ran a couple tests. These are roughly an inch or about 25 millimeters in height. And so I took some other recommendations. I didn't do my speed test on here, but we ran this through. And as you can see, this one was fairly deep and there's not as much contrast. And so that can happen when you use extra power, and maybe it's a look you're going for. But we did get it cut out fairly cleanly. It's not going to be as clean as a CO2. You're going to get maybe a little less of a polished look to it. But it did cut it out and engrave it. But we increased our speed, lowered our power, and here is where you get a nice frosted look to the black, and it definitely has more contrast. Again, we kind of just have that slightly rough look on the edges. So, you know, playing around with speed and power are going to get you a little bit there with the cutting, but definitely on the engraving as well. Now, this isn't going to be something that works on clear acrylic without some sort of binder to it. You're definitely not going to be able to cut clear acrylic, but you can engrave it if you use, like, say, tempera paint to create a binder for it. Another popular thing to do with many lasers, but diode lasers work really well, is slate tile. And so here's an example of one that I did on here. And I ran this after creating the kind of the grid and alignment areas on my spoil board. So I went ahead and just burned that right into the 3/4 inch MDF I have it mounted on. And this ran really well with this. This is run at about 317 DPI and took just about, I think, 5 minutes to do. And I think we were running this again at around 65% power. So definitely something you could do. And with this size laser, you could definitely set up that grid and you could just fire up a bunch of these, lay them out in your grid, and get a lot done in one pass. So one of the big things about this laser is that it is about 30 inches wide. And so of course I had to max that out, and I went ahead and ran this sign. This is on some 1/4 inch. This is a cutoff of some 1/4 inch Baltic birch. And so I went ahead and ran this 2 different ways. I wanted to see how it would do in engraving them all together. And that pass took 1 hour and 6 minutes to do this. Now this is about 5 inches high and again 30 inches wide. And as you can see, I've got my shop logo, kind of saying welcome to my workshop. Got my Instagram and YouTube logos on there, as well as my at Vintari stuff. And so after that, then I wanted to just darken it up a little bit. And so I reran it, but this time I had it go in groups, so it would do each one individually. And then that only took 1 hour and 9 minutes. So really didn't matter which method we used. And as you can see, it was very clean, repeating it. So that kind of goes to their repeatability within 0.01 millimeter. I can't notice that it was off at all in the second engraving, but it definitely darkened it up. And the speed was roughly the same, whether we were doing it in groups or all at once. But you know, the fact that I was able to do this without, you know, cut and print, it was 30 inches wide, one piece, definitely speaks to the advantage of using the width of this laser. So that was of the initial projects I ran through this laser, testing it out over the past couple of weeks, really getting to know this laser and seeing what it can do. So I hope that gave you some ideas to what it is capable of and what I thought of it. So how do I break this down? Well, let me tell you a little bit about my dislikes and my likes. We'll start with a few of my dislikes. I would love to see just a little more depth of information on the build. maybe a larger manual. They do have their wiki. There are a lot of videos out there from them as well as content creators, but it's really nice when they can include kind of a single point reference that has just a little more detail. I think it would help more people. I really wish they had the eccentric nuts on the top side of it. Since I have this mounted on my board, if I need to adjust those, I actually need to loosen it up, kind of take the brackets off of the board, be able to lift it up to make those adjustments. That's not something that you should have to do very often, but on occasion, when you're doing your maintenance, those wheels will wear down a little bit. You're going to need to make those adjustments. It would just be nice if they were on top, easier access, and so it'll be less of a hassle to get at those. Another thing that's a little weird about this one, there is no power switch. So the power cable goes actually through the cable tray and plugs into the board. And once you plug it in, it's powered on, or even when you plug in the USB, it's pulling some of the power from your host computer. And so there's no real power switch. It'd be nice if that was included as well. So maybe if you're building one of these out, you want to put like a powered power strip or a switched power strip in so that you can have a kind of a hard on-off switch for it as well. Now, what did I like about this laser? Well, as I mentioned, I love that I have nearly 32 inches of width and that it's in that format where it's wider than it is deep. It makes it so much easier to work on bigger objects rather than being, lengthy or having to rotate it and having your kind of orientation between your software and your laser be a little bit different. One thing I didn't necessarily mention is that this module is very quiet. It does have those two cooling fans up front, and if you are doing an engraving and you don't have air assist on, you hear the motors running and a little bit of just the laser actuating, but I've had 3D printers that are louder than this machine. It is very quiet. Those fans are very quiet. So from having this be something that's maybe in an indoor area, it's not going to have as much noise as some of the other lasers. The cable management is great. You do have to feed all the cables through there, so you're going to take your time in getting that set up. But once those are in there, they are out of the way. They stay out of the way. They don't snag on anything. They're safe and they're protected. I love to see that. I would love to see this on more diode lasers in the future. So props to them for including that. And as I mentioned earlier, this machine is very flexible in some of the options of how you build it out, how you mount it, where you put your e-stop button, how you're mounting your valves and relays. They have both the M8 and M7 to play around with. They have some expansion boards for it, for even adding some wireless capabilities and such. This laser is a tinkerer's paradise. If you like playing around with your machine, you like modding your machine, adding features to it and such, this is much more of an open platform. It's more intended, I think, for the person who wants to build up their own enclosure, things like that. So it's definitely kind of cool from that standpoint. But as I mentioned earlier, if you're the type who just kind of wants to pull something out of the box and not have to tinker around, maybe that's not what you're looking for. So again, it's a pro, but it's also a con. So I've talked about the specifications, I've shown you some examples and talked about my likes and dislikes. If you are interested in this laser, I will leave some links down below where you can learn more about it, and also some links to where you can purchase it. Some of those links will be affiliate links and they do help out this channel, but don't feel pressured. I just appreciate being able to share this information with you and hopefully help you find the right laser for you. So at the time of the video, this laser is going for $699. I think that's a great deal for this form factor and this size. Yes, you are going to make sure you have a board to mount it to. You're going to need to have an air source for an air pump or air compressor to use the relay. And I would strongly recommend getting the honeycomb panel for it, and that's an additional, I think, $150 as well. But you can still build out this laser for probably right under $1,000 and have a really nice machine, nice working area, nice wide area. And I think I'm going to be excited about this. I'm thinking I'm probably going to be figuring out an enclosure for this. And so you'll definitely be seeing more of this laser in the future. Thank you for checking out this video. Thank you for stopping by. And definitely, if you enjoyed this, hit that like button, leave a comment, hit that subscribe button if you want to see more, because I do a number of these review videos. I do project videos and do some tutorials on using Lightburn and such. So I always appreciate sharing some information, and hopefully you found it useful and want to stick around for more. Otherwise, hopefully I will see you in the future, but in the meantime, I hope you can get out into your workshop and make something too. We'll catch you next time.